go. Double check how much space I have left on the drive. I have 15 gigs left, so there's plenty of space. I think last time, I probably bumped my USB 3 cable, and it lost contact with the drive, and that's why it failed. That was also within minutes, within the beginning of the class too. All right. Okay, the first thing I want to do is to just kind of show you a little presentation that I prepared for the 2 days of exhibition. I'm probably preaching to the choir, but I'll do it anyway, just so that you can watch it and check my mail. There we go. That's my presentation. There we go. Okay, it's all silent. Note it's not science officer, it's computer science officer. We talked about this. And remember, this is targeting middle school and high school students, so. Yep, it's a regular Prius, some gadgets, and okay, right here I have to pause a little bit, because as I was preparing the slide, I forgot one thing. The middle schoolers may not know what inquisitive means. And here's the next slide. Box in a little box. And I think that's really the true hacker mentality, is that. I'll talk about it when I can pause this particular one. Okay, so I just want to take a little pause here to refer to the previous slide. To think outside of a box, it's a phrase, right? I mean, that's a phrase that we all, understand these days. But I think that no one is thinking outside of a box. It's just that some people's box, some people have boxes that are much bigger than some other people's boxes, but they are still confined. Okay. Think about Einstein. Okay, what is Einstein's biggest contribution to physics, to science?
Theory of relativity.
The theories of relativity, because there's general and there's specific. Okay, but even Einstein had problems with quantum physics. Okay, he could not accept the concept of quantum physics, that the electron cannot be it's not in a continuous motion. Instead, the position of an electron is probabilistic. It's here, it's there, and it doesn't have to go through the space in between in order to reappear at a certain space. So I think Einstein had this box. It's just that his box was really, really big to cover the theory that nobody was able to discover before him. Okay, and then some people are more self-driven, and other people are less self-driven. Some people want to be told what to do, how to do it, and how to learn about something, and then some people just want to do it on their own. Okay. And it's almost done. It's not going to waste too much of your time. And many of you are too young to know who he is. I like the last one. Because you can definitely tell there's a cat theme in the whole thing. The next slide, I think we can just kind of skip because, I'm probably preaching to the choir. But this part is kind of interesting. Lots of new and exciting possibilities. I'll talk about that. All right, so you know the website already. That part is nothing new. And then the last part, well, the last one is kind of fun too. So yeah, I'm just going to tell. I was telling the middle school and high school students about the transfer degree, so they know that they can save a lot of money going here for 2 or 3 years, depending on how whether you guys can get the classes that you want to get into. But all this time, you are saving money because you can go to a UC or a CSU and still not be able to get into the classes that you need. Right, so that problem is not unique here at ARC or a community college. It is actually universal, in the entire state of California. Okay, so that's just a little presentation I threw together in 1 hour and a half or so, for that particular show. So what I want to talk about next, and I was just thinking, what am I going to talk about since this class is already ahead of the other class by quite a bit. Okay, and I just got a phone call right before I left my house, and I want to talk about it a little bit. Okay, it's not something that's really controversial and not something that is super duper exciting. It's like this: somebody called me and say, okay, so and so referred you to me because they said that you might be able to help me out. Okay, and it had to do with a biodiesel co-op in Sacramento. I mean, biodiesel. What does that have anything to do with the computer science class, right? Well, as it turns out, all this time, that particular co-op has been in existence for about 6-7 years. And all this time, they keep track of inventory, which means how much biodiesel is left in each tank in each location, who has paid how much money, and who has refilled how much fuel. All of that stuff was, 1, on an honor system, and 2, is paper-based. So people would drive up to these co-op refueling stations, and then they would refuel, and then they look at the meter. They would write down what is the starting point, what is the ending point, how much gallon is in between, multiply that by the price of per gallon, and then leave the cash to the person who is on site. And that's been going on for the last 6 years, okay? Despite technology leapfrogging stuff within the last 6 years. So he told me that it's getting out of hand because people on those locations do not want to deal with the cash, okay? Because you're basically keeping quite a bit of cash around, and it's just not something that people want to do. So he contacted me and to see what I can do or what I can think of to help in this situation. Okay, so do you think it is related to this class or not?
Oh, yeah.
It's a little bit related, okay? It's not an algorithm issue, but it is a programming issue, right? Okay, so I want to ask you guys and see whether you know what to do. I have a pretty good idea of how to approach this whole thing. So let's say I can get a flow meter. A flow meter is basically an electronic device that can measure the flow of something like any type of fluid. Okay, it can report back the number of gallons or cc, cubic centimeter, and so on. Okay, it doesn't matter what unit it's dealing with. Okay, it's just some kind of unit. So let's say I can get a device like that is Bluetooth enabled. Okay, so I can communicate wirelessly through Bluetooth. I have access to a server on the internet. And so what else do I need to come up with a solution for this guy?
A payment system would be for accepting credit cards.
Okay, a payment system. Now, this is a co-op, which means they're not really making money. So they want people to prepay for their accounts. Okay, so they will send in checks to prepay for whatever So people can send in like $100, okay, and they can prepay. And after a while, they want the system to be able to say, hey, so and so, your account is now down to, let's say, $40, which is good for another tank full. Maybe it's time to deposit more money. Okay, so that's how they want to manage the money part. They don't want to go for PayPal because PayPal is a subsidiary of eBay, and the owner of this co-op is very grassroots and decided not to deal with PayPal or credit card companies. Okay, so what do you need in order to complete this solution? We just need a scanner, right? We'll collect all the paperwork. And then use a scanner to scan everything. Now it's all high tech. Okay, what do you do? Okay, think about you as a person using biodiesel. Okay, so your fuel tank is running low. You're going to one of these refueling stations of the co-op. You stop your car and then you basically refuel your car. So what do you want to do from your perspective as a client?
Just identify.
Identify, very good. Now, how do you identify to the system?
Maybe a transponder where it says the code that's specific to the customer.
Okay, a transponder, but a transponder is expensive. Okay, if you're talking about RFID or anything like that, that's a little bit expensive.
Maybe a touchpad.
Okay, a keypad. Okay, so we're going somewhere now. Okay, a keypad and a pin, right? So everybody can have a pin, and you can type it in using a keypad. Okay. What is next? Once you type in, through the keypad, how do you process that information next?
It needs to be relayed to the server to verify the user's identity.
Okay, so you need to send that pin to the server. The server will basically look it up and see whether anyone is, using that particular pin.
Authenticate.
Authenticate. Okay, so that whole process, authenticate and identify, whose account we are dealing with. Okay, so let's say everything is successful. You found the account. So now that person can start to, it will turn on the pump, right? It will turn on the electric pump, so it will be ready to fuel. So as it is being refueled, the flow meter will start to flow. It will start to count the number of ticks, right? So when, go ahead.
First variable, how much gallons are there? I mean, starting from zero, starting from the last time.
All right, that's a very good point. I forgot about that all, completely. Inventory control. Okay, so you need to know how much fuel is left in the tank. Okay, that's very good because if it's running low, then the fuel tank itself needs to be refilled, right? Okay, very good. Okay, now you have the flow meter. Okay, the flow meter is Bluetooth enabled, and it has to communicate with something, right? At the end of the fueling session, what do you do? So let's say the person puts the pump back onto the handle. What do you do next?
Money transaction.
Okay, charge money, but in order to charge money, what actually has to happen in order to charge money?
And to detect how much it's sent out.
Okay, so you have to read the flow meter first to find out what is the volume used. Okay, very good. Next, you look at the price point, you multiply that for the total, and then what do you do with that number?
The number needs to
Database.
Okay, you have to enter that into the database and deduct that much from that person's account, right? Because that much is now used. Okay, very good. All right, so if you think about all of this stuff here, it's not just one single piece, right? You're not just dealing with a single web server to host the database. You need something in the field next to the fuel tank to turn on the electric pump for one, to read the flow meter, to enter the PIN, and also to do any type of display like your account has this much balance left. Okay. Or also if the fuel tank or if the tank itself is running low, it can also send a message to the co-op headquarters and say, okay, this particular location is running kind of low. It's time for someone to deliver fuel to this location. Okay, very good. So what do you use for that purpose?
You could use an Arduino device, I suppose.
You can use an Arduino device, but an Arduino device is kind of difficult to interface with, like a user interface. A keypad you can do, but even so, it's kind of like difficult.
And you would only have a small LCD.
Exactly. So the best solution is a cell phone. because a cell phone may have 4G connection already, so it doesn't really need to have any Wi-Fi connection close to the location. And then two, it has a touch screen, so you can reprogram the touch screen for the pin and also to report how much is remaining in the balance and so on. Okay, a cell phone typically also has Bluetooth, so it can read from the flow meter. And because it has 4G or Wi-Fi access, it can also communicate with the database. In other words, this has everything, all the hardware that I need in order to do the POI, it's point of sale, POS, point of sales, type of application. If I worry about people stealing the cell phone, I can probably do something to attach it permanently to a certain location, or have a security camera to look at it, or something like that. But I don't think that's going to be a big issue, with the theft of the device itself. Yep, go ahead.
I think that's going to be a problem in case there's a disconnection of communication between the cell phone itself and the machine that's Bluetooth enabled. The best way would be to store it in place, like have a small computer in place that will store the data just in case it needs to be backed up.
That's my small computer.
But if the communication disconnects, you lose all the data, and therefore there's going to be a fraudulent transaction very much.
Okay.
Or the lack of a transaction with the permission of the giving of fuel anyway.
Yep.
Or the absence of a transaction.
Well, if you mentioned that people can preload money into their account, you can have that updated onto the local machine that's running the pump, and then it can allow and track the
In real time.
account that's already in progress.
Yeah, there's only one problem with that approach. If there are multiple cars sharing the same pin, they can refuel at the same time at different stations. So if the different stations don't communicate, then you can actually overcharge an account and not know about it. Not likely to happen, but it's possible.
You can bounce the accounts or balance them at a certain time every day or something. And then if connection's lost, then you just fix it before it
Yep.
sinks.
Yeah, but the whole point of this discussion is really just to point out, once you know how to deal with programming, the opportunities are out there. I mean, it really is, out there. I just know the guy. The guy who referred me was my mechanic, and he's one of the people who operate a refueling station for the co-op. And that's how he talked to the co-op owner and say, hey, maybe tech can help you with something like that. But I want to show you, just how what you can do with these devices and why knowing how to program can be very helpful. Before these things become popular, I would say that's going to be a big project. Okay, you have to attach a PC. There's a lot of things that are difficult to do. But with cell phones, everything just becomes a whole lot easier than we think. Like maybe 10 or 15 years ago. Okay. Are there any questions about that part? The discussion that we just talked about. No.
Out of curiosity, how come
Yep.
the other classes are so behind?
It's a big class.
I don't know. The other class is they're just behind. And then, unfortunately, I also have to cancel that class this morning, so that means they're even more behind now, because I had to cancel that class, which is very unfortunate. I'm going to pass the road sheet at this point.
Oh, if your cell phone also has NFC, then users with cell phones could also authenticate that way.
Yeah, but he doesn't want to make any assumption about the end user, so the end user may not have any technology at all. So they would just be, entering the PIN, and that would be the
I was
best way
thinking as
for
a secondary connection method.
Right. Okay. All right. So we are almost done. What I'll do is I'm going to give you, just general guideline. We'll review what we knew about, what we already talked about in pre and post conditions, and then I'll just go through some examples today so that you guys, have a kind of like an overview, a summary of what we have talked about so far and how to apply what we have learned so far on very simple examples. So this is where we are at this point. I'm not going to refer to the notes much. I just want to show you where we are in terms of the notes, and this is what you should be reading. And instead of just reading my own notes, what I'll do is I'll just use examples to illustrate the concepts. I should bump this up back to maybe 16 points there. And double check my recorder just to make sure that it is still recording. Yep, everything is still going. All right, so what we'll do is I will basically give myself an example, and then I'll show you how to work on it when it is a homework assignment. Okay, and also what I'm expecting when you turn in the homework assignment. So I'll start with something like this. I don't want to use the find next example anymore, because we have talked about that like kind of way too many times. So we'll start with something else. I'm not going to ask anything about loops, because loops are quite a bit more difficult to deal with compared to the other types of statements. So we'll stick with conditional statements and assignment statements. I'll do something that's simple as an example. And this is on line 2. Line 2 says if x is less than 20, x gets x plus 2. Line 3, it's else. And then on line 4, we have x gets x minus 20. And on line 5, we have y gets y plus 1. And on line 6, we have and if. And I'll just use that as the entire example that I'm going to use here. Are there any questions about this statement? Yep.
I have a question on pre and post conditions.
Okay, go ahead.
So in order to, my question refers to the forget rule and how to apply that rule
Okay.
to the inverse function rule. So my specific question is, in order to apply the forget rule, the right-hand side cannot refer to the left-hand side?
It's more like there's no inverse function for the right-hand side.
Okay.
But if the right-hand side does not refer to the left-hand side, then for sure there's no inverse function.
Okay. And then the same goes for the function, the inverse function, right?
The same goes for
the inverse function. The same goes to apply the inverse function.
if you can find the inverse function, then you have to use the substitution rule. You only use the forget rule when you cannot find an inverse function for it. Okay, and this one doesn't have any forget rule application, but we'll go ahead and work with this one first, and then later on maybe I can use another example to illustrate when and how to use the forget rule. Okay. All right. So for now, we'll just deal with this one, and let's say pre1 has something already. Okay. So pre1 basically says x is greater than or equal to 0 to begin with. Okay. That's what we know about x. On line 1. So right off the bat, we know x is greater than or equal to 0, and also, we'll go ahead and say x is less than 40. Yep. Go ahead.
If you were doing this on the that pre-calc thing, and how you have like the comment line number, and then you do like X.
No. This is a trace. So this is a trace. We're not going to use a spreadsheet to do it. This is not a trace. This is a step-by-step proof. So we're not going to use the technique that we use for tracing.
Because that wouldn't work.
I wouldn't use a spreadsheet to do it. I would just use a text editor like the way I'm doing it right now. Okay. So that's the precondition. You don't have to ask why the precondition of line 1 is like this. It's just given to you. The next step is to work on which lines. You tell me what I should work on next.
Are we assuming that condition is true or false?
We are assuming that's the precondition, which means it is true.
So it's true.
So we are assuming that x is greater than or equal to 0 and x is less than 40 is true as a conjunction before line 1 executes.
So then we should make
That's
that,
why it's a precondition. Yep.
So then pre1 would then go again and just say x is greater. Wait, never mind.
Line 4.
So we can work on there are two lines that we can start to work on right away. Line, okay, so we work, okay, after line 1, where can I go?
Line 2.
Line 2 or
Line 4.
line 4. Okay, so those are the two lines that we can work with at this point. Okay, so we have pre-2 and pre-4 that we can work with. I just used, I just picked 2 first, and then we'll work on line 4. Okay, so because of the structure of the conditional statement, pre-2 is really pre-1, so I keep everything in pre-1, and then I can also confirm at that point that x is less than 20 has to be true. In other words, this part here, where the blinky cursor is on, is just because of the structure of a conditional statement. Because otherwise, I would not be about to execute line 2 if the condition is not true. Am I doing okay so far? And then pre-1 is still here because between line 1 and right before line 2 executes, I don't have a chance to modify any of the variables. So whatever was true before line 1 still has to be true right before line 2 executes. Okay? So that's why I'm writing it like this. And then after that, I would just go ahead and expand what is pre-1. Pre-1 is just whatever we have here. So I'll just do a quick copy and paste. But don't forget the condition of the conditional statement itself. So right now, we have a statement that looks like this. Okay. At this point, what am I going to do? Now, you can do a simplification, but since simplification of a Boolean expression is really not within the scope of this class, I'm not going to require you guys to do anything like that. So you can leave pre-2 the way it is like this. On the other hand, if this seems kind of obvious to you that we can do some simplifications, let's go ahead and do some simplifications. Okay? How am I going to do simplifications here? We can drop the middle one. Very good. And the reason why we can drop the middle one is, now I know it's intuitive, okay? But why are we dropping the middle one?
Because we know that x is less than 20.
Because
X less than 20 and
it is
x less than
implied
20.
by something else, right? Because x is less than 20 implies x is less than 40. Okay, now if x is less than 20 implies x is less than 40, and we already know that x is less than 20, so we know x is less than 40 for sure. There's no need to mention it again if it is always going to be true. So that's why, optionally, it is not required. You can also, simplify this so that it's just simply x is greater than or equal to 0 and x is less than 40. Okay, but in this class, you do not need to do the simplification, but I do want to point it out because it is kind of important for people to start to notice and say, hey, I think I can simplify this a little bit. The reason why it is important for you to know how to simplify something is if you are a developer, a programmer, and this is somebody else's code as a condition of a conditional statement, you really need to understand, hey, this just means that x is greater than or equal to 0 and x is less than 20. Because if it is your job to debug somebody else's code, you have to understand the actual content or the logic of the code that somebody else has written. Is that reasonable? I mean, okay. And most of the time, as the first job as a developer, you are going to debug somebody else's code. I mean, that's usually the way it is. Okay, so we'll just call that, pre-2. Pre-4 is about the same thing. Pre-1 is still true because if I'm about to execute line 4, that means I don't have a chance to modify any variables from line 1 just yet because I have just confirmed that x is less than 20 is not true. Okay, so just to be sure, okay, I'm not going to jump any steps. This is the way I'm going to write it. Pre-1 is still true because I don't have any chance to change any variables before this. And this negation is also true because otherwise we wouldn't be here. Okay, I'm about to execute line 4, which is the beginning of the else branch. That means the condition of the conditional statement has to be false. Are we doing okay so far with this line of pre-4? Okay. Now the next line is just expanding everything and also turning the negation into a non-negation. Okay, pre-1 is still the same thing as before. X is greater than or equal to 0 and x is less than 40. And on top of that, we can now say it is not the case that x is less than 20, but that really is the same thing as saying x is greater than or equal to 20. Are we still doing okay? The negation, I just turn the less than comparison to greater than or equal to. At the same time, eliminating the negation. Yep.
Why did you add 40 again? X is less than 40.
Because that's a part of pre-1.
Oh.
See, pre-1 is given to me already, and it is also here, so I'm just expanding the content of pre-1 in the second step. Now, in this class, if you just give me this as an answer, that's going to be okay. I'm not going to take any points off, if someone just gives me that. But I do want to show you or point out that it can be simplified. Okay. Now, when you look at something like this, it really helps to rearrange things a little bit before you say, oh, okay, I guess it can be simplified. So if I rearrange things like this, then it becomes more obvious why it can be simplified. Yep.
Before we drop one of those, would we have to rearrange it if we wanted to drop one? Or you would
You don't have to. If it seems obvious to you, you can just kind of drop it. But even that, the entire step is optional. You don't have to do it. Yep.
So what if on a test we don't need to really show everything, we just write down the actual answers?
You have to write the first line and at least one more line for that purpose. Okay, this line you have to write because that line shows me that you understand the structure of a conditional statement. And then the next line is also important because the next line is the actual condition itself. Okay, so those two lines you have to write. The simplification is optional.
So basically the condition, the implied condition, and then the solution, would that be enough?
Say again?
The actual precondition, the first line, the second line, which is an implied condition, and then the final simplified condition is enough?
Yep, I would say so.
Okay.
Yep, the first line is because of the structure, so you have to show that. And then the second line is just expanding all the terms that you refer to in the first condition. Yep.
Yeah, can you explain that 40 again?
The 40?
Yeah.
Why
Can you
is
say-
there?
Yeah.
It's because pre-1 already has it.
What
What's
is
our
it?
given condition?
It's a given condition, and we don't
We don't know why.
we don't
just-
explain that.
Okay.
Yeah. Yep. But it's in the pre-1, and because pre-1 is referred here, so that's why when I expand pre-1, I'm gonna have to include it. Okay. Now that we have rearranged things a little bit, can we simplify the first two items of the conjunction? Okay. Which one do we drop?
X is greater than or equal to 0.
Yep. Because the second one is more restricted. X is greater than or equal to 20. And x is less than 40 becomes the conclusion of the precondition of line 4. Okay, very good. All right. So now that we have pre-2 and pre-4, we now have two ways to proceed. We can work with post-2 or we can work with post-4. Okay, so either way is fine. I'll just go back here and work on post-2. So when you're writing your notes, you don't have to write in the same order that I'm writing. You can just kind of use the same order that I'm talking about. But because I'm using an editor, I can always go back and insert additional lines. And let me check the recorder. It's still recording, so if you run out of time or if you cannot write as quickly as I can type, you can just kind of focus on the content and what I'm talking about instead of frantically writing down everything. Okay, so post-2 is based on pre-2, but in order to determine what we have to use to determine post-2, we have to first think about what kind of a statement is line 2? What is that?
Replacement?
Sorry?
Replacement statement?
Okay, you already jumped one step. What kind of statement is line 2? You got the right answer. I know where you're coming from.
Assignment.
It's an assignment statement, okay? With an assignment statement, there are only two ways to get from the precondition to the post condition. It's either using the forget rule or using the substitution rule. How do I decide which one to use? Flip a coin. No. Okay, go ahead.
Determining if it has an inverse.
To see whether the right-hand side has an inverse. Okay, very good. So what we'll do in this case, and this is what I expect from your answer, also, as a homework assignment and also in the test, is to do this. Okay. So what you need to do is to tell me, okay, this. Okay, the right-hand side of line 2 is, okay, so I'll use a function to describe it because, you know, in case it has an inverse function, I want the notation to say what is the inverse function. So f of x in this case is x plus 2, okay? It has an inverse function of f prime of x is x minus 2, okay? Now, you don't have to use exactly the same words that I use here. You can simplify if you want to, but I do want to know two things. One is what is the right-hand side of that assignment statement? And two, does it have an inverse function? If it has an inverse function, what is it? So those are the things that you have to indicate one way or another. You don't have to use exactly the same words because I know it has an inverse function of blah, blah, blah. It's kind of wordy. Okay, you can say, you know, f prime exists and it's blah. Okay. All right. The next statement is also important. So you can say, because of this, we apply the substitution operation rule, whatever. They all mean the same thing in this class. So we apply the substitution operation because it has an inverse function. If it does not have an inverse function, then you have to apply the forget operation. Are we doing okay so far? Yep.
What if the right-hand side doesn't refer to the left-hand side?
If it does not refer to the left-hand side, it automatically does not have an inverse function. Okay? Because where you are mapping x does not even depend on x. So there's no way you can reverse the operation. Okay? So let me say that again. If the right-hand side does not even mention the left-hand side, it is automatically no inverse function. Okay? But in this case, it does have an inverse function. Yep.
And so would this rule apply to any time we're doing an assignment statement, or?
Every time you deal with assignment statement, you have to assess which rule, you have to assess the assignment statement itself and then determine which rule or which operation we have to apply in order to go from the precondition of that line to the post condition of that line. Okay? So in this case, we apply the substitution operation. So this is what I expect from everyone when you turn in an answer. So you basically say the post condition of line 2 is the result of a substitution operation. And in the substitution operation, I need 3 pieces. Okay? The first piece is, in this case, the precondition of line 2, which is what we are starting out with. The second thing is, what is the variable on the left-hand side? Okay, in this case, it's variable x on the left-hand side. And then the third piece is, what are we replacing x with? In this case, it is f prime, the inverse function, applied to x. So this line is mandatory. You have to give me this line here because this shows me that you know that, okay, this is the general form of applying the substitution rule. Okay? The next line is to expand what is actually pre-2. So in this case, I have a slight advantage of being able to copy and paste. X is x. There's nothing to do with x itself here. But you also have to tell me what is f prime of x. So in this case, f prime of x is x minus 2. I always use extra parentheses to emphasize x minus 2 is one thing. Okay, treat it as one thing when we do the replacement operation, because otherwise you can put x minus 2 at a place where it is ambiguous. Okay, do we do the multiplication first or do we do the subtraction first? This makes it very clear we have to do the subtraction first and then do whatever rest you have to do. Okay. The third line in this case is the actual answer. The actual answer is just do the substitution. So I will just copy whatever is the first item in the substitution, and then every time you see x, you replace it with x minus 2. Oops. Every time you see x, you replace it with x minus 2. And that is all that I expect you to do. Some of you can decide, hey, I can actually do some simplifications here because I can add 2 to both sides. It becomes x is greater than or equal to 2. That's okay. If you want to say x is less than 18 on the second one, that's okay too. You can do some simplification if you want to, but that part is optional because this is not an algebra class. But at this point, up to this point here, it does not involve any type of algebra. Okay, it's really just syntactic type of changes. Yep.
Is it less than 18 or
22, you're right. Okay, because we're adding to both sides. You're absolutely right. So I'll go ahead and do that substitution here. So we have x is greater than or equal to 2, and x is less than 22 because we're adding to both sides. Thank you. All right. So that really answers the question of what is post 2, and now we can do the same thing to post 4. So post 4 is basically the same thing, okay? In order to figure out what we have to use to deal with post 4, we have to, kind of figure out this part here. Does the right-hand side have an inverse function? And in this case, it's x gets x minus 20. It definitely has an inverse function. So what you do is you say the right-hand side of line 4 is f of x equals x minus 20. Now this is the worthy way to do it. You don't have to do it this way. But I need to know what is the function and what is the inverse function, okay? Inverse function is f prime of x is x plus 20. Therefore, we use the substitution operation. And then the rest is kind of like, post 2, except it's slightly different. Post 4, in this case, is based on the substitution of pre-4. The variable on the left-hand side is still x in this case, and then we apply f prime to x as the thing that we replace it with. And then the rest is kind of just copying and pasting a little bit. F prime of x is x plus 20. And then the third step is actually applying the substitution operation. So now we have x plus 20 is greater than or equal to 20.
Slow down,
One
Ghostwriter.
too many.
Slow down.
Sorry? I'll slow
Too
down a little bit.
fast.
Okay.
Yeah, that's why we're ahead.
I like that debugging logic.
Why do you
It's all getting recorded too, so if you cannot, copy everything, that's okay. Some people, work better when they're copying, when you write it down on a piece of paper, you understand better. Some other people just want to focus on the concept, especially when it's all recorded, they can actually play it later on. So it depends on the person. Some people learn things differently. Okay, so I'm just gonna wait for all the pins to stop. Okay. When I went through college myself, it's worse than this because my professors, they have taught the subject matter for so many years, so they have overhead projector slides prepared, and that's the worst. That is absolutely the worst because one, the projector slides were prepared using regular font, so it's like using 12 or 10-point font, so it's really, really dense, okay? It's really hard to read to begin with. I chose a pretty big font to make sure that the entire class can read it comfortably. And then the second thing is my professors did not have to write anything himself or herself. So they just slap that sheet on, they talk about it, and then what happens next? Slap on the next one. And was the whole thing recorded? Absolutely not. So if you miss it, you miss it, man. I mean, there's no way. You just have to frantically ask all the friends around you and go, "Did you copy that?" No.
I'm following all of this, but like in the beginning, why did it have to be 0, 20, and 40? Like, why did X have to be between all that?
Well, this is just a particular example. It actually resembles.
It was just assumed it was
Those were all assumed. This code actually has a particular meaning, and I can explain that too. So it's not like I just picked something in random.
Okay.
Yeah, this code actually has a particular meaning why we do something like that. I can explain that. Yep.
There's a similar question like this on the test. Will you have the precondition in one assumed for us, or will we have to?
I will give you the precondition.
Okay.
Yep.
Because if there's no like numeric thing that you've assigned to it, then you can't do an inverse function too, right?
Yeah, you can. Yeah, if I say x gets x plus k, the inverse function is x gets x minus k.
Oh, but then if you just put in x gets k, then there's no.
If I give you x gets k, then the right hand side does not refer to
Or
the
to
left
not
hand
to
side
sides,
because
yeah.
k does not refer to x.
Okay.
Okay, so in this case, we are just one step away from being done here, and this step once again is optional. If you give me up to here, you get all the points already. But for those of you who look at that and go, that doesn't, that's just not the way I want it because it can be simplified. So we'll go ahead and subtract 20 from both sides. So now we get x is greater than or equal to 0. And the other side is x is less than 20. Does that look familiar to you?
A little bit, just a little bit.
There's a reason, right?
Yeah.
Okay. So now we have just one more statement. Okay, we have pre-5. Okay, what is the precondition of line 5? Let me show you the original code here. We are done with this line here, and now we have line 5. Line 4 and line 5 are sequential. In other words, we execute line 5 after line 4 just because one is following the other one. Okay, so there's no branching here. There's nothing conditional about going from line 4 to line 5. So what do you think should be the precondition of line 5?
Why? Oh, actually.
It's just
Post
post
forward.
forward because the two lines are sequential. Okay, one is following the other one, so the post condition of line 4 naturally becomes the precondition of line 5. Okay, and if I want to, I can just explain it here because they are sequential. Okay. Any questions about this part?
Would you go past the next step and write down next to, like, post 4? Would you, like, expand it out?
No, you don't have to expand it out because it's kind of understood. You can trace your way back pretty easily this time. Okay, so now we have to work on post 5, right? So we have to apply the same type of rationale here. This is line 5. The right-hand side is y plus 1, but the variable being changed is y. Okay, so is y, if f of y is y plus 1 reversible? Does it have an inverse? Okay, that's very good. So that's exactly what we'll write here. We'll just say the right-hand side, okay, or you can abbreviate everything, okay? Right-hand side is f of y is y plus 1. Inverse is f prime of y, which is y minus 1, okay? You just undo it by subtracting 1, and then you can just say, therefore, use substitution operation. And that's it, okay? So if you want to abbreviate everything, you can just do it this way. For those of you who use a lot of math proofs, you can use the 3 dots instead of therefore. You guys know what I'm talking about?
Mm-hmm.
Okay. Yeah, not ellipsis. It's the 3 dots. Is it a triangle? Yeah, it's a triangle. 3 dots. So you can just use that to instead of therefore. So dot dot dot. And then the rest. You don't have to write out therefore. Okay. And then the rest is just I think at this point you'll be a little bit. Is anyone a little bit bored at this point because it's going to be about the same thing again? It's a good sign, okay? Because for people who are not bored and still trying to figure out what is going on, you need to study a little bit, okay? If you're absolutely bored because you know exactly what to do next and it's just really the same trick reapplied again, that's a good sign because now you are actually doing okay, okay? But this one is kind of funny, okay? This one's kind of funny because I forgot one little thing in the precondition that makes this substitution operation a funny one, okay? It's a little bit different from the other ones. So we have post 5 here, and it is the result of the substitution operation applied to pre-5. We locate all the occurrences of y in this case because y is the variable changed on that line. And we replace every single occurrence of y with f prime applied to y. Just like that. So this part is nothing new. We have seen this before. The next line looks kind of suspicious. Okay, so we'll go ahead and take a look at the next line here. This is the precondition itself. We look for all the occurrences of y and then replace every single one of those with y minus 1, which is the inverse function relative to the right-hand side. And then the next line is to carry out the actual operation. Okay, so you just say, okay, I want to find all occurrences of y and replace every single one with y minus 1. We have a little bit of a problem here, don't we? Because there's no y, okay? If the precondition doesn't say anything about y, and all I can say now is y is 1 more than it was before, I still cannot say anything about y. And that will be the answer. That's it, okay? Given the precondition that I gave you, that is the only answer you can give me. That's, okay? Is that working out okay? All right. All right, so now we have post, yep, go ahead.
What if y wasn't a variable referring to x and it was a character instead?
If y, okay, what do you mean by y is a variable that refers to x?
As in y updates x. Oh no, y, I meant x updates x. So this, well now I confuse myself.
I think he means, what if y was instead of a variable, a letter, like a normal letter?
Yeah.
A normal
Letter,
Just a
like
character.
the letter y, that doesn't mean anything, it's not a variable. That's what he was asking.
Well, since y appeared on the left-hand side of an assignment statement, it has to be a variable.
I meant on the right hand side. What if
On the right-hand side,
x was plus 1, but it wasn't a variable, it was just a character?
like a constant,
Yeah.
you can treat a constant like a variable. It's just that, it once it got a value, it never got changed.
No, I'm saying the y character can't have a value, it's just a letter.
Just a
It
letter.
doesn't have a value. It's just a character.
Like it's actually the letter y.
So it's a string.
Just a
Like
letter
a-
y.
you're talking about like
It's just a placeholder, but that's the same thing as a variable.
How would you apply the inverse function to a character or string?
You cannot, because it has to be something
It has to be
that
like
refers to the variable on the left-hand side in order for it to be reversible.
Okay, that was my question.
Okay. Yep.
Hmm?
Oh,
I know,
sorry.
it's working it out in my head.
Okay.
Why did we get rid of y again? How did we?
We never started with y.
We never
so
had
we
a y.
never really got rid of anything because we never started
It
with
was one of
1.
the original precondition.
Yep.
Had we started with y, would we have to put that y value in along with the inverse condition?
Yes, if I, it's a little bit too late, but if you want to, you can actually go back here and basically say, what if I told you something about y is non-negative? Now that would propagate all the way through until we get to that point. Then we can say something about, oh, y is now greater than or equal to 1.
But until then, we have to carry it with us.
Right, but since I did not start with this, that means, by the time we got to line 5, I did not tell you anything about y before line 5 executes. So even though I know that I just added 1 to y, I still cannot tell you anything about y because we didn't start with anything that we know about y.
That's just error.
Okay, it's information.
Well, it's not necessarily an error. It's just, in this code, that's the way it is. Okay, and that's the right reasoning too. Because if I give you,
See,
this is the problem of an uninitialized variable. Okay,
Yeah, so
because with an
it's because you have to
uninitialized
do y.
variable,
Right.
So y has to be like, you don't have to worry about it being updated because there's just nothing to worry about there. So
But
y,
then it's doing a -1 though, and this is like.
but y has no
Still-
value, so there's no point in tracking it because all you're gonna do is gunk up the system.
it's because we don't know anything about y. It's kind of like y being an uninitialized variable. If it's uninitialized, we don't know anything about it.
Right.
So if I say, okay, here's a variable y, it has a value, but we don't know anything about that value. Okay,
Right.
I just added 1 to it. Can you tell me what the value is?
Runtime error?
No, it's not a runtime error. It is still unknown.
So
Okay?
it's unknown, so it's kinda to keep it in
Unknown
there.
plus 1 is unknown because you don't know what it is.
Yeah, so keeping it in there pretty much turns into excess information then.
Sorry?
So by keeping the y -1, sure, we know that it's in there, but actually putting it down is just excess information. So we just don't include it?
No,
or-
it's just because we blindly apply the substitution operation. Just
Okay.
because the right-hand side of the assignment statement has an inverse function, we just apply the substitution operation. But the result of the substitution operation is correct
Oh, yeah,
because
no,
we didn't
that's
know anything about
just,
y.
Just not making any sort of notation about it.
Because we cannot.
Yeah, that's what I'm saying. It's just pretty much a floating piece of excess information.
Right. Because I didn't tell you anything about why we still cannot know anything about why. Yep.
So is that the same thing we had on our homework with more nesting? We had an unspecified variable?
Right. But at this point, did I well, when I applied the substitution operation, did I say, oh, this is a special case because y was not in the precondition?
No.
Not at all. I just blindly applied the substitution operation.
Follow the algorithm.
Exactly, and that's exactly what we want to do, is to have a set of rules where you can just say, oh, this is under this condition we apply this operation, under the other condition we apply the other operation. Okay, because that's the only chance you have to have a chance to automate something like this. The only part that is not mechanical is to figure out what is the inverse function. That is the only part that requires your thinking, because you have to think, oh, okay, adding one, subtracting one. Okay, they cancel out each other. Multiplication, division. Okay, but that's the only part that requires your input to figure out what is the inverse function. The rest of it is really just, oh, okay, inverse function exists, substitution rule. Substitution is just a substitution, right? Replace every single occurrence of the variable on the left-hand side with the inverse function applied to the variable. There's no special consideration other than what I just mentioned. Is that okay? Okay. All right. So now that we have post 5 and post 2, we can work on post 6. Now when you summarize the post condition of an entire conditional statement, I want you guys to restate this is the post condition of line 2 or the post condition of line 5. Line 2 or post condition of line 2 or post condition of line 5. This has to do with the structure of a conditional statement. Okay? You branch off to two different branches, but when they merge, when you're standing at the merge point, you could have come from either one. So that means one of these two conditions has to be true. But you cannot say one and only one of these two conditions can be true, because they can overlap. Okay, post 2 and post 5 can overlap. Let's see whether we have a situation like that here. Okay. All right. What is post 2 and what is post 5? This part is just copy and paste from my perspective. I'll give you enough time to copy that.
So post 5 is because it's post or pre-4?
Say again?
Post 5, why not post 4? Because it follows post 4,
Because
right?
line 5 is the last line of the else branch. We have to use the post condition of the entire branch to feed into the end of the conditional statement. Okay? So this is a prime example of why we want to use a regular or instead of a either or. Because you can see the two conditions. Let me just highlight which one we are talking about here. If you look at this condition here and you figure out, oh, okay, so x can be 2, 3, 4, 5, all the way up to 21. And then you look at the other side of the disjunction, and in this case, x can be 0, 1, 2, all the way up to 19. Do they overlap?
Yes.
Yep. So if I say either or, that means a lot of those common values cannot be the value of x. But in this case, they certainly can be. Are there any questions about this particular example?
Can you restate again?
Can you yeah, I was gonna say, can you
repeat?
Okay, this time I cannot quite remember what I said.
Either or and
The reason you don't use either or is because the values overlap for both post statements. So if you were to do either or, it would pretty much say, because you have the overlap, you would pretty
For
much
instance, x can be 5 from either side.
So it's not the one, right?
Hmm?
And then you
Well,
said-
because x equals 5, x can be 5 from either side, I cannot say either or, because if I say either or, that means x cannot be 5 after the conditional statement. Any questions? I could have actually replayed the recording file itself,
So you wouldn't simplify this anymore? Like this would be the end, or would you want this simplified more?
No, it cannot be simplified. Well, I suppose it can be simplified a little bit. I don't think it can be simplified anymore, because the two sides are overlapping, but one is not containing the other one. So we are looking at a classic Venn diagram here. Let me find a pen to draw it. Okay, right there. Okay. So we are talking about post 2 is this particular set, but it's actually an infinite large set, but we'll just kind of use this as an example. And then post 5 is this set here. So they do overlap a lot. Okay, it's actually not infinite. In this case, it's finite, especially when these are integers. So the portion here that is overlapping is 2 all the way up to 19. Those are the possible values of x that are overlapping from both sides. Now, on one side, it can also go to 20 and 21, and on the other side, it can also start with 0 and 1. So that's why they are overlapping, but one is not truly containing the other one. And in this case, you really cannot simplify any further. Yep.
Do we put it as 2 to 19 and 20, 21 or 0, 1? Unify the center, that's a constant, no matter what, it's the same thing, and then the or plays on the 0, 1 and then 21.
Oh, I see. Yeah, you can do that.
It's basically the same thing with different words.
X is within the range of 2 to 22, or X is within the range from 0 to 20. So we're looking at the union. So yeah, you're right. There is a way to unify the whole thing. You can just say, X can be from 0 to 21 in this case. So it can be, yeah, you're right. It can be simplified in this case. All right. Any questions about this? Okay, so let's go back and look at the algorithm one more time, and I'll explain. Oh, okay, wrong slide. Okay, right. I just shrunk it. There you go. Okay, so let's go ahead and look at this code again and say, but why do we have something like that? What is it going to do? All right, so instead of the Venn diagram, I'm going to draw another picture here. So we'll go ahead and draw a little picture like this. We have, this is y, and that is x. So let's just say that x starts with an initial value of 0, and so is y. Okay, so I'm adding some more, assumptions here. X is 0 to begin with, y is 0 to begin with, and somehow this code is stuck in a loop. So I'm going to execute it again and again and again. Okay, and more than that, I'm going to say I'm going to plot x and y for each time I execute this code here. Okay. So the first time I execute x and y are both zeros to begin with, so we are putting a dot here, right? The next time x has a value of 2, because it goes through line 2 and we add 2 to it, nothing is happening to y because x is still less than 20. So the next time x is going to be 2 here, and then the next time it's going to be 4, 6, 8, 10, 12, 14, 16, 18, okay? And now x is 20. But when x becomes 20, what happens to y? Y gets incremented here. Now x gets thrown back to 0, so we go again, and y goes here. Okay? But what if x is there's another variable to keep track of the actual x, so it doesn't actually reset to 0. Then we'll be drawing 9 dots here, and then we'll draw another 9 dots here, another 9 dots here, and so on. We are actually drawing a linear slope. Okay? This is how computers draw lines, a straight line, and it doesn't involve, is there any multiplication or division involved in this code here, from line 1 to line 6? Nope. So why is that important? I mean, most of you already know how to plot a line, right? I mean, y equals m, the slope, times x plus an intercept plus c, right? I mean, we know about this equation. This equation has one little problem. It has a multiplication. Why do you think multiplication is a little bit of a problem?
Create slope.
Because it's slow. Because it is a slow operation. What are we talking about? My Pentium processor has 4 floating point units, and they can complete a multiplication in a fraction of a second, a tiny fraction of a second. So why is this a problem? Well, try to do this with a 6502 processor in the original Apple II computer. Okay, it's a 1 megahertz 8-bit processor that has no hardware multiplication. Now, when you don't have more hardware multiplication, it means if you want to do multiplication, you will have to implement multiplication using your own logic, using only addition, subtraction, and comparison. That's going to be time consuming. All right? But doing something like this is very easy and very quick, even with a 6502, a very simple processor. Addition, subtraction, and comparison are extremely fast operation regardless of what kind of processor you're dealing with. Multiplication, division, and stuff like that can be very slow with a processor that has no hardware multiplier or dividers.
I was talking to a programmer at my job, and he was programming in like the 60s or something.
Okay.
He was saying that he would do this to, obviously they had Fortran or whatever they were dealing with back then.
Yep, you would do optimizations, because your hardware has limited resources. And then someone, and I can see the faces, saying, but this is all irrelevant now. I mean, we have super fast processors. Who needs to deal with something like this, for optimization? If I need multiplication, I'll just do multiplication. I'm not going to do any optimization so that I can avoid the use of multiplication. Well, that's not entirely true, because we still have processors that cannot do multiplications really fast. I will show you exactly what I mean by that. Okay, and this is really another type of specialized programming that is kind of important to some people. So I'm going to go to a company called DigiKey. They sell electronic parts, components, and stuff like that. So if you design circuit boards and stuff like that, this is a really, really helpful website. I'm going to look for a part called AT-Tiny. And AT-Tiny is a microcontroller unit. There are close to 1,000 units related to that. So we'll go ahead and look at tape and reel. So we are ordering huge numbers of these things. We are going to run it at a lower clock speed. And let's see here. We can do a scroll here. Program memory size. I think this will give you an idea of what we are, in which direction we are going. Program memory size. 256 by 16. What does that mean? Are we talking about 256 megabytes at least? I mean, if we're not talking about gigabytes, at least we have to be talking about megabytes, right? No, we are talking about 256 times 16 bits. So each instruction is 16 bits or 16 binary digits long, and it can only have up to 256 instructions. We are not talking about the number of lines in C. We are talking about simple instructions. Each one can only add 2 numbers, subtract one number from another number, compare a number with another number, or move a number from one place to another place. And we can only have 256 of those in this particular part. All right? All right. And they still sell parts like these, okay? For a very specific reason, for a very good reason, okay? So we'll go ahead and specify T. Okay, I think that's probably enough. I'm not going to specify any more. Say everything is in stock, apply filters. No parts. Okay, so I have to uncheck certain things here to find it. Okay, so there we go. Apply filters. There we go. We have several parts that will fit that requirement. One part is a SOT 23-6. So we'll choose that one because I'm kind of familiar with that form factor. Operating temperature goes from negative 40 degrees Celsius to 125 degrees Celsius. That's more than boiling point, hotter than boiling point. So you can put that thing in boiling water and it keep operating like no problem. Don't try that with your Pentium processor. Okay, so we have the parts here, and look at the price here, unit price.
That's what it's
36 cents each when you order these things in huge 4,500 quantities. Now, why would you order 4,500 of these things at a time?
Manufacturer?
Mass.
Because you are making and manufacturing Furby 2. Does it make sense? I mean, if you're making Furby 2, you're not going to buy in 4,000 units. You're going to buy these things in 450,000 units at a time. So you get the price break, and the price point is 36 cents each. That is why, because you want to minimize the cost of whatever you're manufacturing, right? So if you can save a few pennies, in parts, you're going to save a few pennies in part. But because you're saving a few pennies, in parts, now you cannot say, oh, we'll just do multiplication, right? No problem. Or we'll just use division. You have to really think about how to use those 256 instructions available to you. Are you guys seeing why we still worry about things like that, even though your Pentium processor has tons of processing resources?
Do like a daisy chain on all those things? No. I was like, do a daisy chain on one of those things. And
some of these can be chained. They actually can communicate with another using a bus, using I2C or SPI bus. Are there any questions about parts like these? Does anyone want to know how big these things actually are? I deal with this particular form factor a lot, because I design electronic boards and other things too. So I'm looking at my own pinky, which is probably medium size. Some of you probably have bigger and others have smaller ones. So if you look at the fingernail on your pinky, I'm just kind of counting right here. I can fit probably 9 of those chips on the fingernail on my pinky, and you can see my pinky is not particularly big. Okay, and I can put 9 of those on mine. That's how big these parts are. Yep.
How do you solder the electronic things?
How do I solder those? Oh, I have really good techniques to do that. So when you these are called surface mount parts, which means they're not through-hole parts. You don't have holes for the entire part or the pins to go through. So for this part here, it has 6 pins, right? So on the circuit board, you have what we call pads. You have basically 6 pads or copper parts on a insulator, and these are exposed copper. So what you do, or what I do, is I will put solder on one pin. Okay, I would just carefully use my soldering iron, heat up the pad, and then heat up solder, and just drop a little bit of solder on one single pin. And then what I do is I would use a pair of tweezers and carefully place one part over the position where it's supposed to go, and then I would heat up the solder, the little bit of solder on this little pad here, so the entire part will sink, will just settle in place, and then I will remove my soldering iron. So this part here will basically start to cool down and it will solidify. Then the whole part cannot move anywhere because one pin is already pinned down. Then I will solder the other 5 parts. But I do have to tell you, when I'm doing something like this, even when I had good vision before I had to use the bifocal, I still need I think it's a 2.5 times magnifying loop to do it. The magnifying loop also has a prism built into it. In other words, I don't have to actually cross-eye myself because the prism actually does help me to focus on something that is close. And that's how I do soldering like that. I still do that every week, because it's part of a job that I cannot get rid of. Yep. So are there any questions about this? No questions? Yep.
Do you buy some of those at Fry's?
No, you cannot buy these at Fry's, unfortunately. You can still buy these, in lower quantities. If you buy one, it's 65 cents. So you can still buy these things, from DigiKey. The shipping is going to be a whole lot more than the parts. So, but if you like to tinker with stuff like this, you can definitely do it. I think you guys are missing one important question. Nobody has. Okay, go ahead.
How do you program one of these?
Exactly. How do you program something like that? The programming is done by the same pins. Okay, the 6 pins here. Let me just kind of give you the data sheet. Okay, what we call data sheet in industry for this particular part here. This is a 3D rendering of the pin here. It doesn't tell you what is the actual size of that thing. So here we have the data sheet. So for anyone, any engineer who needs to work with something like this, they will have to read the data sheet to figure out how to do it. And the data sheet has programming instructions. I'm going to scroll down a little bit here. There we go. So we have, okay, for those of you who know a little bit of electronics, this is ground and this is VCC. So you only need these 2 pins to give it power. Okay, and once you give it power, your ground and VCC, then the whole thing can operate. The programming pins, let me see which page has the programming pins. It doesn't tell me. It's usually close to the bottom of the document, so I'm gonna scan real fast here.
You can try control
Control one.
Yes.
command.
I'm gonna search for it, so I'm gonna do a slash. This is Chrome. Nope, doesn't work.
Chrome doesn't have control find.
Control 5.
No,
Control F.
Control F5. Yeah.
Not F5.
No,
It's
just
F.
F. Control F.
Oh, Control F. Search. Okay.
Sweet.
Obvious. I was using slash, because that's in VI. Okay, so we want to look for programming, voltage, programming logic. There we go. On page 106. Doesn't say what the pin outs are for programming, but basically you use 2 or 3 of the pins for programming, but those pins can later on be used for the application too.
So do you just solder jumpers to it, or where would you usually enter the circuit?
The typical way to use one of these things is you lead the programming pins to a header. Then you can plug the programming device onto the header in order to do your programming. Yep. I have not really used this particular part, but I have used the larger parts. So they have 6 pins for programming. This little part definitely does not, need 6 pins to be programmed. The programmer itself is about $20 or so, and it's USB. It's a USB device. So you attach the programming device to your computer through USB, and then the other end of the programming device you plug onto the little header on the circuit board. So you don't even have to desolder the part in order to program it, because that would be kind of problematic. having to desolder it to program it and then put it back on, that would be so lost in decade. Yep. And I worked with devices like that too. Does anyone know what is a EEPROM? Do you know what EEPROM stands for? Okay.
Electronically erasable memory.
That's double EEPROM. That's EEPROM, which is already one huge step, from EEPROMs. EEPROM stands for erasable, programmable, read-only memory. Okay, and the way those things works is you can program it. They come unprogrammed, so you can program it using a special programmer. So you have to take the chip out of the board to program it, and then you put it back onto the board to test it. Now, if your program is not behaving correctly, then you have to erase it before you can reprogram it. Erasing those things is basically exposing it to UV light for about 15 minutes. So you have to pull those things out of the circuit board, put it into a tray, stick it into a little device that will basically have UV light to shine on it for about 15 minutes. And it has a little timer that sounds just like your regular kitchen timer. Okay, so it goes
Throw it in there. Go have some coffee.
ding. Then you can reprogram it. So I started programming with those things. And those 15 minutes gives me a lot of time to really think about what went wrong with this program. The only thing I can use to debug a program is not like what you guys can do, like a full GUI. You can stop the program, look at the variables, like what we talk about in this class. Okay, the post condition of a fail condition is the LED did not turn on. That's it. Okay, that's the only indication that the program did not work.
You can't tell where it failed?
No, it's just the LED did not turn on. So I'll see you guys on Tuesday. Have a nice weekend.
So time consuming?
Oh, it is. Yep.